Hi everybody, Brian Rathbone from Broadband Catalyst here. In partnership with LISC's Broadband Help Hub, part of the National Broadband Technical Assistance Marketplace, this video will discuss broadband internet access and how it is delivered to our homes and businesses. First, let's define internet access and broadband. The internet is a global computer network that moves data around the world. Broadband refers to internet access that is reliable, high speed, at least 100 megabits per second download and 20 megabits per second upload, with latency of less than 100 milliseconds on average. We'll talk a bit more about these terms in a moment. Internet speed refers to the number of bits that can be simultaneously transmitted or received. Download speeds refer to the data transfer rate from the internet to your computer. For example, when streaming movies, you are primarily downloading content. If, on the other hand, you are uploading a video to YouTube or another service, you're primarily uploading data from your computer to the internet. There are some key broadband speed terms that we should define. Bits are the most basic unit of information transfer that we use to understand the speed of an internet connection. Terms we use to define the number of bits a connection can transfer per second include bits, a single unit of information, kilobits, 1,000 bits, megabits, 1,000,000 bits, and gigabits, 1,000,000,000 bits. We also use symmetrical and asymmetrical to define the difference between download and upload speeds. Symmetrical connections, with equal download and upload speeds, are ideal for telecommuters, content creators, and those using telemedicine. But asymmetrical connections with slower uplink speeds than download speeds are currently more common. Having an asymmetrical connection is often like having a highway coming into your location, but having a dirt road going back out. Another term you will hear is latency. This refers to the amount of time it takes for an internet request to travel round trip from your computer to the internet and then back again. Latency is measured in milliseconds, and high latency will make many applications perform poorly or fail to function at all. Internet service with latency that exceeds 100 milliseconds on average is considered to be high latency service, which is often not eligible for broadband funding, such as those dollars allocated to the BEAD Broadband Infrastructure Grant Program we will discuss later in this video. To sum up broadband speed and latency, we can use a highway analogy, where the number of lanes in either direction determine the speed of the connection. And the speed limit on that highway, combined with traffic, determines the latency, which can vary widely. Jitter is a term used to measure how much an internet connection's latency varies. If latency is always low or high on a given connection, the jitter will be low. If latency is low at times and higher at other times, then the jitter will be higher. Jitter is measured in milliseconds and reflects the difference between the highest and lowest latency over a given period of time. Speed, latency, and jitter are commonly measured using internet speed tests such as speedtest.net, Measurement Labs, fast.com, and other similar sites. Let's examine the data carrying capacity of DSL versus fiber. If we use water as an analogy for data, DSL is like pushing data through a 2-inch pipe, while fiber is like having a mile-wide river. The width of the channel determines how much water, or data, can flow, and this is essentially the origin of the term bandwidth. In this analogy, the river is the band, and the distance from side to side is the width, bandwidth. The most common type of broadband for homes and businesses is wireline service. These types of internet often use existing lines that have already been constructed and connected to the premise. Copper lines have been retrofitted to provide DSL service along with traditional voice services. Coaxial cable lines that were deployed to bring cable television into our homes have been retrofitted to provide cable internet service in addition to traditional video service. The cost to deploy these services is greatly reduced whenever existing infrastructure can be used instead of having to deploy new infrastructure. When deploying fiber to the premise, the cost to build from the curb or pole to the premise can be very high and must be accounted for. While fiber to the premise is considered the most future-proof technology for broadband deployments, it is also the most costly infrastructure to deploy. Fiber optic service is the gold standard for broadband in terms of speed and latency, and it has the most potential to become faster as technology improves. Upgrading fiber internet speeds generally does not require the fiber to be replaced, just the electronics on each end of the fiber. All types of internet access utilize fiber optics. The primary question is what technology is used to bridge the last mile connection to the fiber optic superhighways. In the case of fiber to the premise, fiber optics are used all the way to the household or business. DSL service, on the other hand, uses copper telephone cabling to bridge the last mile. Wireless internet of all sorts use radio frequencies to bridge the last mile, and cable internet uses coaxial cable, also known as coax. Fiber can reach speeds well in excess of 1 billion bits per second, also known as gigabit, and the latency is often lower than 10 milliseconds. The challenge is that deploying new fiber lines is expensive, especially that last mile connection from the curb to the home. Fiber lines can be deployed aerially using utility poles, which is generally the most cost-effective way to deploy, but it also leaves the fiber vulnerable to weather, farm equipment, and other hazards. Another way to deploy fiber is by burying it, which can be as much as twice the cost of deploying aerial fiber. Buried fiber is not immune to being dug up or otherwise damaged, but it is considered to be more reliable than aerial fiber. Wireless internet services include fixed wireless, mobile or cellular wireless, and satellite. Fixed wireless is a type of internet access that uses an antenna at the premise to connect to a nearby tower. The antenna doesn't move around like a cell phone, which is what makes this type of service fixed as opposed to mobile. Fixed wireless providers can consistently allocate the correct amount of bandwidth due to the fact that their users always connect to the same tower, which makes fixed wireless less costly to provide than mobile wireless service. Among the primary limitations of fixed wireless service are the inability to pass through rock, soil, and often buildings. Having clear, substantial, and unobstructed line of sight to the tower from the premise results in the best possible service, especially as the distance from the tower increases. The closer you are to the tower, the better the signal and foliage penetration capabilities tend to be. Premises that are behind trees often experience lower levels of wireless coverage and service. However, this has been improving through the use of radio frequencies that are licensed or licensed by rule, which helps to improve coverage and foliage penetration capabilities and limit the interference that has long plagued unlicensed fixed wireless service. Mobile broadband is what our cell phones use to connect to the internet when we are roaming or not connected to a fixed internet connection via Wi-Fi. As we move around, our devices seamlessly upload and download data from different cell towers we pass. This is very convenient, but can be trickier for providers to manage consistent speeds when consumers can roam between different towers in a way that is largely unpredictable. This requires mobile providers to have excess speed capabilities at each tower in the event of many mobile users converging on a single tower, which also tends to make mobile broadband more costly to deploy and use. Mobile broadband also tends to incorporate limits on how much data you can transfer. These limits are commonly referred to as data caps. In addition to the higher cost and data caps, mobile service often suffers from high latency and jitter, which are among the reasons it is not considered sufficient and reliable as home or business internet service. It is important to note that many mobile wireless network operators are now offering fixed wireless from their towers. The primary issue with this type of service is that mobile users tend to take precedence over fixed broadband users, which means that fixed wireless users on mobile-capable networks often experience slowdowns in their service when mobile usage is high. It is for these reasons that many states are not considering licensed fixed wireless service from major mobile wireless providers to be reliable broadband. One important distinction between mobile wireless and mobile broadband is that mobile wireless connectivity includes voice, text, and data, whereas mobile broadband only refers to the data portion of mobile wireless connectivity. Traditional satellite internet uses geostationary satellites that are always at the same location in the sky. These satellites are roughly 22,000 miles from Earth, which leads to high latency due to the 44,000-mile round trip for every data request. Newer, low Earth orbit satellite arrays, like Starlink, use many smaller satellites that are only around 300 miles from Earth, which improves speed and latency, but does not improve latency enough to be considered true broadband service for the purpose of the BEAD and other federal grant funds. With that said, low Earth orbit satellite represents a huge improvement of Internet of last resort and has the potential to improve over time as more satellites are deployed and new technologies are developed. Wi-Fi has become ubiquitous and is often used interchangeably with broadband to imply the existence of Internet access in a given location. Wi-Fi itself doesn't provide the Internet connection. It just extends the reach of an existing wireline or fixed wireless connection to allow devices to connect wirelessly within a small area, like inside your home, business, or at a coffee shop. Even in the case of public Wi-Fi, the actual connection to the Internet is generally provided by a wireline circuit, most commonly a fiber connection. In summary, the main sources of broadband for homes and businesses are wireline services like fiber, cable, and DSL. Terrestrial fixed wireless is growing in popularity and availability, and services like mobile wireless and satellite access represent service of last resort for homes and businesses, although often with the benefit of mobility. Wi-Fi helps extend the reach of a broadband connection over short distances. Household and business density in a given area has a dramatic impact on the cost of deploying wireline and wireless services to customers. Dense areas with more than 15 locations per mile of roadway can often be deployed with costs as high as $1,500 per location or more. In areas where there are between 3 and 15 locations per mile, costs can exceed $5,000 per location. And in rural areas with fewer than 3 locations per mile, costs can exceed $25,000 per location, making it cost prohibitive to deploy wireline service. These low-density areas are often considered good candidates for terrestrial fixed wireless service, but the costs are high even for wireless providers, and pairing high-cost areas with lower-cost areas may be necessary to provide a sustainable business case. There are numerous additional factors that can increase the cost per location in a given area, such as mountainous or rocky terrain, tall trees, rivers, estuaries, and ecologically protected areas. As of 2024, when this video was recorded, there are 2 primary federal programs that are funding broadband infrastructure deployment and digital equity efforts. The largest funding source is the Broadband Equity Access and Deployment Program, BEAD, that will distribute $42.45 billion for broadband deployment, and the Digital Equity Act will distribute $2.75 billion towards digital equity and inclusion. The United States Department of Agriculture, USDA, also has 2 long-standing programs that support broadband infrastructure deployment. These are the Reconnect and Community Connect programs. In conclusion, there are a variety of technologies and industries that can be used to deliver robust, reliable Internet access to households, businesses, and community anchor institutions. Fiber optics underpin all types of Internet connectivity, and the cost and performance of your Internet connection are largely determined by the technology that connects the last mile to the middle mile, such as fiber, coaxial cable, or wireless transmission. Thank you for your time, and thank you to Lead for America, LISC, and the Broadband Help Hub for their support in creating this video.